students, I hope all of you are doing good. Let's start today's chapter, Basics of Geometry. The three building blocks of geometries are points, lines and planes. Point. A point is an exact location in space, like this. This is a point. It has no length and no width. We represent a point by a dot and label it with a capital letter. Some representation of point in everyday life are like a distant star in the sky, the tip of the pen or pencil, zero mark of your ruler, and vertex of a square. Okay. See, we can name this like point A, point B, point C, whatever. Line. A line is a straight path of points that extends on and on in both directions which are not ending. The length of a line cannot be measured. To show that a line extends endlessly in both the directions, we use arrowheads at both the ends. A line is named by using any 2 points on a line. Thus, the line given below is named as like this, AB. These arrows show that this line can be extended endlessly in both the directions, right? See, this is a line. A horizontal line goes straight in right and left. Okay, line, this is line AB, line BA, and this is vertical line. Vertical line, and this is horizontal line, right? This is your vertical line, so horizontal line. A vertical line goes straight up and down. A line can also be curved. A curved line is called a curve. For example, all these are curves, right? Next, line segment. A part of a line is called a line segment. It has a fixed length that can be measured. The points at which the line segment begins and ends are called its endpoints. Every line segment has 2 endpoints. The given line segment has C and D as endpoints. It is named by using these endpoints. It is named by using these endpoints as CD or DC. In the given figure given below, which is the shortest path that can be followed by the rabbit to eat the carrot? Obviously, A to B, that is path 2. So, path 2 answer, as you can see, path 2 represents line segment which with carrot as one endpoint and rabbit as the other. Okay, a line segment always has an initial point, okay, and an end point. It cannot be extended in either directions. Okay. A line segment is also the shortest path between 2 points. Some representation of a line segment from your everyday life are a matchstick, an edge of your tabletop, an edge of your laptop. All these are line segments, you know. Now, ray. A ray is a straight path that has one endpoint and goes on and on in one direction only. This ray begins at point P and goes through point Q. See, it has an initial point. This is P point and this is Q. Okay, this is the sign of arrow, and we can extend this arrow infinitely or endlessly in one direction. Okay, it doesn't stop at point Q, right? We name the given ray as PQ, where the first letter is always the end point. First letter, that is, it is the end point. This symbol shows that a ray has a fixed end point and extends forever in other direction. A ray of light from a torch is the most common example, right? Plane. A plane is a flat surface. In mathematics, a plane goes on and on all directions without end. We usually work with just a part of a plane. Points and lines lie on a plane. A plane can be named by using any 3 points on it. The given figure shows plane ABC. The order of the points does not matter. Some representation of a plane surface from your everyday life are, these are the plane surfaces. Okay. Method, there is no boundary of the plane, so these all pictures are parts of one plane, right? Exercise 9.1. Which of the following has a fixed length? A line has a fixed length? No, we can extend a line in both the directions. Whether a ray has a fixed length? No, because it can also be extended in one direction endlessly. And a line segment, of course, it has a fixed length. And what about a point? A point doesn't have a length, right? Now, angles. What is an angle? An angle is a figure formed by two rays meeting at a common end point. These are two rays and they are meeting at common end point, which is P. So this is angle. The common end point is called the vertex of the angle and two rays are called the arms of the angle. Look at this picture, you can form some idea of an angle. The symbol for the word angle is this. Okay, see, as I told you, these are the two rays, this is the vertex, okay, which is the common point. These are the arms, okay. You can name an angle in three ways, using a three-letter name in the order, at point at on one ray, a vertex, and a point on the other ray. That is, you can write either angle BAC or angle CAB, but remember vertex should be at a middle, okay. Number two, using only one letter name, that is a vertex A, angle A, okay. This can be used when there is only one angle with this vertex. And number three, writing a number within the rays of the angle and naming the angle using this number. Example, angle 1, right. Now, interior and exterior of an angle. The inside of an angle, that is the region between the rays, is called the interior of the angle. Point P is in the interior of angle C. This is angle ABC and point P is interior, inside the angle, okay. Point A, B, C, D, okay. A, B, C and D. These points are on the arms, or also called side of the angle. The points of the plane that do not lie on the arm or in the interior of the angle are in the exterior of the angle, okay. The points Q and R are in the exterior of angle ABC. Now, measurement of angles. When a hand of a clock turns from one position to another, it changes its direction. You can show this change of direction or a turning by drawing into two arrows from one point. You can think of an angle as an amount of turning of rotation. The pictures here show how the hands of a clock turn through different angles as they rotate. Look at this. The picture shows one complete rotation. Okay. See, these are the angles made by the clock. Okay. And this picture is showing one complete rotation. The least amount of turning that brings the hand back to its starting position is called one complete rotation. By measure of the angle, we count the amount of rotation. Just as there are standard units of length, of area, of weight, etc. There are also standard units for the measurement of angles. The standard unit of measure for angle is the degree, and the symbol for degree is this. Okay. If one complete rotation is divided into 360 equal parts, then the measure of each part is called 1 degree or 1 degree. The angle formed by one complete rotation measures a 360 degrees or 360 degree. The drawing below show angles of 15 degree, 30 degree and 70 degree. Number 1, if a circle is divided in 40 equal parts, what will be the measure of an angle of each part? So what will we do? Angle formed by one complete rotation is a 360. So we will divide a 360 degree by 40 degree. Okay, so what will we get? 4 nines, 9 degree. That means measure of angle of each of the 40 equal parts is 9 degree. Number 2, calculate the angle between neighboring spokes on each wheel. As the wheel circle is divided into 4 equal parts, see, it has been divided into 4 equal parts. So the measure of equal part is, we will divide 360 by 4. So we will get 90 degree. And in B part, the wheel is divided into how many parts? 3 parts. So we will divide this by 3. So we will get here 120 degree. And in C part, the wheel is divided into how many parts? 8 parts. So we will divide 360 degree by 8. So we will get the answer 45 degree. Right? Measuring an angle. The instrument for measuring angles is called a protractor. The diagram on the right shows a protractor. It has the shape of a semicircle and the angle at the center is divided into 180 degree. Note, the inner scale of protector is marked 0 to 180 degree anti-clockwise. See, 0 to 180, this is inner scale. And the outer scale of protector is marked from 0 degree to 180 degree. 0 to 180, this is the outer scale, okay. This is inner scale and this is outer scale. And the outer scale of protector is marked from 0 to 180 degree clockwise, and each small division is 1 degree. To measure an angle less than 180 degree. Step 1. Place the center of the protector at the vertex of the angle. Here you will place, okay, and make sure that a 0 degree line of the protector is placed along one arm AC of the angle with point A at the center of protector. Step 3. Read the value on the protector as indicated by the other arm, that is AB of the angle, okay. So we'll find that angle BAC is equals to 70 degree. Always use a scale with 0 degree on one of the arms of the angle, okay. In this case we are using outside scale, so the angle is 150 degree, and in this case we are using inside scale. Here also the angle is 150 degree. To measure a reflex angle, what is a reflex angle? An angle that is greater than 180 degree. Suppose you are required to measure angle X, okay, angle X, this is reflex angle, this is greater than or more than 180 degree. So step 1, measure A, angle A, okay, then reflex angle, that is a BOC. What will be angle BOC? We will minus angle A from 360 degree, and then we'll get this angle, okay. Drawing angles. To draw an angle that measures 70 degree. Step 1, draw any ray OA. Place the protector such that its center may fall on O, the end point of the ray. Align the ray with the 0 degree mark of one of the protector scales. The end point O of the way will be the vertex of the angle. Step 3. Using the scale on which the ray OA aligns with 0 degree, mark the point at 70 degree. Label the point as B. Step 4. Remove the protector and join B to O, then angle AOB is the required angle. Okay, so you need a protector to draw an angle, okay. Note, as you can see, we have drawn these angles using the inner scale on the protector. What will be the angle like if we use the outer scale on the protector? If you use the outer scale of the protector, you will get this angle, okay. Maths alert. The sides or arms of an angle are raised, so the length of the sides and drawing an angle do not affect the measure of the angle, okay. Here, irrespective of the length of the arm, each angle is equal to 90 degree. You see here, arms are shorter, here arms are longer, but that really doesn't matter because measure of each angle is 90 degree, okay. Equal angles or congruent angles. When two angles have the same angle measure, we say that they are equal or congruent, and write angle ABC is equals to angle DEF because they are equal, or we can say congruent. This means that either angle can fit exactly over the other, okay. If we keep this angle over this angle, they both will fit, okay. Or if we keep this angle over this angle, again they will exactly fit over the other angle, okay. Now, kinds of angle. Angles are named according to their measures between 90 degree and 180 degree and 360 degree. The side OA has turned through an angle between 0 degree and 90 degree to position OB. So, angle AOB is called an acute angle. It is less than 90 degree, okay. Now, OA has turned through 90 degree to position OB. So, angle AOB is a right angle, means which is exactly 90 degree. Next, OA has turned through an angle between 90 degree and 180 degree, and angle AOB is called an obtuse angle. Obtuse angle is greater than 90 degree. OA has made half turn to position B just opposite to position of A. An angle of measures 180 degrees called straight angle, okay. And a straight angle is always equals to 180 degree. Now, OA has turned through an angle more than 180 degree but less than 360 degree, and angle AOB is called a reflex angle, means greater than 180 degree but less than 360 degree, okay. Now OA has made one complete turn. This angle AOB measures 360 degree and is called a complete angle. Complete angle means an angle of 360 degree, right? Identifying the different kinds of angles in your environment. See, this is right angle, okay. This is right angle, this is making right angle. Acute angle, these angles are less than 90 degrees, so these are acute angle. Now obtuse angle, see this angle and this angle, all these angles are more than 90 degree, okay. And straight angle means 180 degree. This is straight angle, this is straight angle, this is also straight angle, right? Let's do exercise 9.2. What kind of angle is shown in each figure? Okay, let's check this out. This is acute angle because this is less than 90 degree. This is right angle and this is obtuse angle because this is more than 90 degree but less than 80 degree, okay. And this is straight angle and this angle is reflex angle, okay. Now types of lines. Parallel lines are lines on the same plane that never meet, no matter how far they are extended. They are always at the same distance apart. The symbol, this symbol is used to show is parallel to, okay. Here line AB is parallel to XY and line PQ is parallel to RS, okay. See, these parallel lines never meet. No matter how long you extend them, they never meet at any place, okay. They always, and the distance between the lines remains always the same, okay. The following some of the representation of parallel lines in everyday life, okay. Railway tracks. Have you seen railway tracks? These are the parallel lines. Or like in cricket also you have seen the stumps. These are the parallel lines. This line is parallel to this line is parallel to this, and also the legs of the table are also parallel, okay. Intersecting lines are lines that cross each other at a point. Think of a red light where two roads meet and cross each other. That's why we call it crossing. See, two lines crossing each other, these lines are called intersecting lines, okay. Line AB and CD are intersecting at which point? At P, okay. The letter X is also an example of intersecting line segment, okay, which I have made. So this is also an example of intersecting line segments. Next, perpendicular lines. When two intersecting lines meet to form right angles, they are called perpendicular lines. They are indicated by the symbol this, a square corner. In the diagrams, line AB is perpendicular to line CD. In short, as line AB is perpendicular to line CD, okay. And this is the symbol for is perpendicular to, right student? So here comes the end of this chapter, and now you will do practice of the remaining questions and exercises, okay.